Welcome everyone to This Week in Svelte, episode 135. Sorry for my shitty hair, I don't know why, I keep getting this very bad hairs. Thank you for joining, and we don't have a showcase today. I really wish I could find more stuff. Not because I'm not trying, I don't know why I don't find interesting stuff anymore. So feel free to ping me if you have some interesting stuff that you want to see on This Week in Svelte. But let's jump into the changelog and we'll see what can we say. Okay, so we start with Svelte 5.53.12 6 days ago. Update select __ value on change. So this is a small trick that we use. So basically we store the actual value of a select inside __ value. So if you have used a select in Svelte, you might not notice, but the value is secretly stored within an __ something inside your element itself. So if I have 0, 1, 2, and I do bind value like this, yeah, that's so value should be 0, the number value should be 1, and value should be 2, just for good measure. 2, and let's also print value. And basically now this select has inside the element, so if I inspect the element, it has on the element itself. So if I select, I can do $0 here to get the select, and you will see that inside the select I can do $0 __ value, and you get 1. And if I change this, I now get 2. So that's a small thing that we do. I mean, for select is actually needed because select does not have a value. So we need to store the information that you bind somewhere. But we also do that for inputs because I can't remember why we do it. I think it's because it's probably, oh yeah, obviously. That's the reason, because the value that you have on an input is not necessarily the value that you selected, is the value that you are currently typing into the input itself. So it's a getter, so we couldn't use that. So we use this __ value on your elements. Don't say that out loud. So chore add invariant helper for debugging. This is something very interesting, and in general I think it's a very good practice to also do this on your in your projects. So if you have some assumption about the code, you can have an invariant, which is basically, it's a very simple function that basically just, where it is, here it is. So you pass in a condition and a message, and if the condition is false, it will throw an error with that message. This may seem very silly, but it's actually very useful. For example, I don't know if there is some invariant here. No, there's no. But I can technically search for invariant, and we can see a few instances where invariant is used. So for example, here we can see that this is not something that is specified in code. Like TypeScript will not yell at you here. It's just an assumption that you have about the code. So we know that if sources.length is greater than 0, then probably batches.routes.length needs to be equal to 0. If this, and we make this assumption here, and it might not be true. And if it's not true, then we might need to change the code so that, like, to figure out why it's not true and if that could be a problem. And so the fact that we have this invariant here, like batch has scheduled routes, it means that we now get basically an error. So like when you are developing your application, you can, yeah, it's basically just like an assert function. It's basically just there to say, like, this needs to be true. And if it's not true, then it's an issue. And if you see this issue, in fact, if you see if we go back to the PR, the error that you get if by any chance during dev you get an error like this, the error that you get is an invariant variation occurred, meaning Svelte internal assumptions were flawed. This is a bug in Svelte, not your app. Please open an issue at blah, 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 citing the following message. So this is basically a way so that if by any chance our assumption about something that needs to be true were flawed, you can open an issue and we can then start figuring out if that's the case. So it's a silly thing, maybe like, why would you throw an error, blah, 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 but it's a very nice small thing that you can add to your library if you have some assumption about the code. And yeah, like there's also this, like, invariant was not guarded by a dev because it needs to be guarded by dev. Okay, so ensure derived values are correct across batches. As I've said before, there is a lot of work that is going on around batches because batches in general are a very complex topic. Simon, Rich, and Elliot mostly are working on this. And the point is, like, since the introduction of async, what can happen is that basically multiple batches of reactive values can be active at the same time, and because of the async nature, and it's very complex to keep everything in track. And so again, like derived values, for example, needs to be correct across multiple batches. So like there probably were a bug where we can actually take a look. Let's take a look. Yeah, capture derived updates as well, so they become part of the current previous, so that batch values computation is correct. For example, when using state.eager with a derived. Yeah, so it was fixing this issue. Opening Svelte-check. Okay. Yeah. So in every batch, basically what we do is that we keep track of what was the previous value, what was the next value, because when we start a new batch, what we need to do is basically we apply some work, but then we need to time travel back so that in the application is not shown until the async work resolve. So it's a bit of a weird thing, but it is working and they are nailing down all the issues. Fix handle async right-hand side assignment in assignment value stale. If you remember last week, I think we talked about right-hand assignment. When you're assigning something, we are checking that the right-hand part of that assignment is not stale. There are, like, I've explained this a bit last week, but the point is we were not handling the async part of it. So if there was an async expression inside this assignment, it was not handled correctly. Avoid traversing clean routes. This is also probably, so the routes are like every time you have you do an effect.route, which by default we do for you when you mount the app. That's the start of a reactivity graph. And when we schedule something, we start from the root. And I guess we were traversing all batches drew from the same queued root effect, and did reset them to the empty array when starting a flush. After refactoring, roots are scheduled per batch. So again, each batch basically has its own root effect that is scheduled or not scheduled. So again, very complex stuff. Okay, let's see. 3 days ago, fix ensure inspect after top level await doesn't break builds. Inspect has been a source of multiple bugs. The reason is that inspect is synchronous instead of the rest of the like reactivity being asynchronous. I mean, not asynchronous, but like, for example, when you make some change, effects generally run in an asynchronous way, in the sense that they wait a microtask before executing. Inspect is synchronous. Sorry. And this sometimes does mean that you are basically accessing values that are changed immediately after they are being set, and that can lead to some problem. So, yeah. Resume inert effect when they come from off screen. So there are some, like there is a flag that we set on effects that is inert. So if an inert effect is basically an effect that is not, like we don't need to ever execute that effect. But like then we need to resume those effects when we actually need to execute them. And if they came from off-screen, so that's another concept in async Svelte, where basically some of the changes are applied off-screen and then brought to the actual screen, and some effects that were coming back from off-screen were not actually being resumed. There is an interesting question, so I'm gonna highlight this message for a second and then continue talking. The question is, will there ever be any performance focus on Svelte-check? And the answer is absolutely yes. There are already performance focus on Svelte-check. So I don't know if we talked a bit about it in the last, so let me open github.com, Svelte.js, language tools. So a few weeks ago, Svelte-check released a new version that basically added a couple of, these are just the shims, that added a couple of flags that allow for much better I'm looking for the, here it is. Provide incremental and TSGo flags. So those are two flags basically that improved the performance of Svelte-check by a lot by doing two things. First, the TSGo flag, as it might suggest, is using the TypeScript Go binary. So that's just faster because TypeScript Go is faster. The incremental one is also doing something clever, which is instead of keeping the file system in memory, we actually write to the file, which means that we can just check the new files instead of rechecking the whole thing, basically. I think, I mean, Simon worked on this obviously, so I'm not sure exactly how it works, but those two things already gave a pretty big increment, like improvement in terms of performance. In general, like we are trying to find ways to make Svelte-check faster. There are also a couple of rewrites. There is a Svelte-check Rust Svelte-check Rust. Yeah, Svelte-check Rust, which is basically like they admittedly they vibe coded this, but basically this is doing the parsing with Rust. It's doing parallel transform and it's using TSGo. And as you can see, like there is a lot. I mean, on Worm, like it's up to 30 times faster. Obviously, like this, it's cool, but it will need to catch up with Svelte-check. So, yeah, take that with a grain of salt. But what I mean is, we are trying to get inspiration from these things to see how if we can make things faster, like in the Svelte-check by itself. Yeah, okay. There is a message that say that TSGo is failing for me. I haven't got the chance to open an issue for it. Yeah, if you have time to open an issue, we will definitely figure out what's going wrong. Okay, let's go back to the changelog and we can see don't eagerly access not yet initialized functions in template. Okay, I see what's going on here. So, hey, this is a tank invoking a function. Let's flatten that logic because the bug where lazily initialized function were eagerly referenced in the template effect. That caused a null pointer exception. So if you add something like this, yeah, we were basically, let me see, like this is, yeah, it's the old one. It was invoking the function before it was declared, basically. Not sure where this is. But regardless, the point is, we were making a transformation that was okay, yeah, so basically, okay, I see what's going on here. So when you have a tank which is invoking a function, so if you have a situation like this, for example, I don't know if this is now completely removed, but let's say that you have something like, it's in a derived, yes, probably a derived. Let's say that you have a derived. Derived, and let's say that I have a function that is, oh, I think that's not even, okay, so, I don't know, get, okay, so this is a function, and I'm returning name from it, like this. Now, if I do stuff like this, like, let's say that I do derived.by, and I do get, now this logic here, like these characters here, are literally the same thing as doing this. It's the same thing because it's just a function that it's invoked, and as soon as it's invoked, it invokes a function without any argument. And so if you did something like that, to save you some bytes, in the output, yeah, now it is removed, but I guess before that PR, so like if, let me see if I do this, for example, no, maybe I can't remember how to trigger it, but the point is, there are some situations where basically instead of doing this, we rewrite your code to do this so that it is like less bytes. And however, that had the problem that if you lazily initialize the function where eagerly referenced in the template effect, that caused the null pointer effect. So yeah, that was it. It's a weird combination. Uh, discard batches made obsolete by commit. So when you commit something in a batch, so basically, again, the batch, there's a lot of work around the async Svelte, but basically when like a batch can be committed. So as I've said before, in the batch, when you execute a new batch, you are kind of wrapping all the state changes that happen when that batch is active inside that single batch. So like inside that batch, you have all the state changes that happened, and then you press, like, not you press, like you invoke the commit function, and that that batch apply. However, it might happen that some batch is made obsolete when you commit. So all the old batches are made obsolete, and they were not discarded, and now they are. So like what could happen is that like an old batch was maybe committed later and it was changing some values. Ensure is standalone child correctly reset. Yeah, I think this was a problem with okay, so is standalone child is basically so basically like in Svelte, when we compile your code, if you have like, if there is a node that has just one single child, we slightly optimize your code in a certain way, and to determine if it's standalone child, we are setting a variable inside the state of the compiler basically, and it was not reset, which meant that if someone set it to true and then you were not a standalone child, but it was not reset, it was incorrectly assuming that you were a standalone child and do an optimization that it couldn't do. Remove nodes in boundary when work is pending and HMR is active. So this was like a slight fix to the HMR logic, which, to be fair, like it is quite the logic. So how HMR work in Svelte, so how HMR work in general, let me see if I can show you. So let's say that I open, because I was actually working on it before. So let me show you the code for this. So the HMR, when you, let me show you the code, how the code is compiled when HMR is a thing, okay? So this is your Svelte component. So in this case, this is the component that I was compiling. And this component, it's a very simple component. Like you're just importing a component and then passing the props. And this is how this component gets compiled. So you have the client and you have main.svelte.js. So there is a bit more stuff here, like the Svelte CSS wrapper, the component and stuff like that. But the interesting bit, like to learn how HMR work, is this bit here. So this, like, it's a bit thing, to be fair. Like I think it's actually like some sort of convention for HMR in general. But basically the point is, this if import.meta.hot is available, this means that HMR is available. So like basically Vite, when HMR is enabled, it will add hot to the import.meta object. So import.meta is something that it's available in the browser. So I mean, import is something that is available in the browser, but if I open this and I do import.meta, I mean, yeah, you cannot use import.meta outside of a module, because like the console is not a module. But if you are inside a module, it's something that you can actually use. Let me see, can I show it to you from the playground maybe? I would assume if I do console.log import.meta, okay, I think it's not failing, so I can probably show it to you. Yeah. So import.meta, you can then, like, the default thing that you can do is access .url. So if you do import.meta.url, this is basically representing the current file you are in, the current it's the current module that you are in. So you can access these in Node, you can access these in the browser. Most importantly, import.meta is an object. And now what happens is that, like, this is something that is pretty standardized, but you can basically put stuff into import.meta, and Vite does exactly that. So for example, you might have seen inside a Vite project import.meta.glob, which is to glob some files that are handled by Vite. Another thing that Vite does is it had this import.meta.hot, and what this is basically it's an object that has a bunch of function on it, and there is also this import.meta.hot.accept module. And so this function, this is a callback that gets registered on Vite, and under the hood, Vite is using basically a WebSocket. So when you enable HMR inside Vite, what happens is that the dev server inject a WebSocket connection. So it spin ups a WebSocket server. It injects the connection to that WebSocket, and then whenever you press save on a file, it sends an event to that WebSocket, and that WebSocket is basically invoking this callback. And the module is basically the new module that you created. So let's say that I have a file and I do export default 43, for example. This will be like module.default will be 43. And if I do export const stuff is equal 43, and whenever I save, this will have module.stuff is equal to 43. So module is basically this file that you are changing. It's the new shape of that file. And so basically what you can do is that you can wire up the HMR yourself, and it's up to you to do whatever it takes to get the new module and update the values on the page, basically. So this is how hot module replacement works. In Svelte, what this means is that, as you can see, when you have this file, which is the main.svelte file, we create this function here, which is the main function. But then instead of exporting default main like this, what we do is that we wrap this function with this HMR function. And this HMR function, what it does is that it basically wraps this function here with a signal. So we actually use Svelte reactivity to take this function, and we return this function here, which is a function which is also, it's a function, but it has a bit more logic around. So as you can see, we create a source for it with the function, and then we wrap the component with this logic here, which basically does the hard wiring. So like it invokes the component, it checks if it's the same component. If it's different, it creates a new branch and it mounts the component to the anchor. So like it's doing this HMR function, it's doing the plumbing of mounting the component for you, and then we export default that function. So like this is how HMR works. And all of this was just like a nice detour from the changelog, but this was just basically a fix to that part of the code base to basically add 2 extra comments that we can use to then remove the boundary, basically. Sorry, this was a bit of a convoluted way. We have a new feature, a new minor, which is allow CSS, rune, and custom element compiler option to be function. So this is something that we kind of already had, but just with Vite plugin Svelte. So if you're using Vite plugin Svelte and you want to have dynamic option, you can use the dynamic compile option for Vite plugin Svelte. But now this is actually baked in directly into Svelte. And so if you are using the Svelte compiler, not Svelte compiler, if in your Svelte config, basically now the CSS, runes, or custom element property can be function. And not only they can be function, they can, basically they accept the file name. And I think also the code, probably. But basically the point is you can then, based on the file name, figure out if you want to enable CSS or not, for example. So yeah, that's just a nice thing that you can now do. Rain state, reactivity loss tracking. So this is just a small bug fix. No, it's not, technically it's not even a bug fix, it's just a chore. But basically, like, this is the how is it called? This is the warning that you get when you are awaiting stuff that, I mean, when you are reading some state after an await, not in the proper way. So if you do stuff like that, you will get a warning now. This was already a thing before, but it was a bit buggy. And so now it's actually reinstated and it is actually working. Okay, so that's it for Svelte. And let's see, we don't have any new release for SvelteKit. Let's see if we have any new release. We have a new release of the MCP, which fixed broadened checks for imported runes because LLMs are unhinged. This is my comment. So while working with LLMs, I recently came to the realization that we were making some check. So in the Svelte MCP, we are doing some check so that if the LLM wrote something like this, import from, I don't know, Svelte/runes. So if the LLM did something like this and imported state, for example, because sometimes, the fact that you don't need to import the runes, it's something that sometimes the LLM doesn't get very well. And so, especially if it's an older model that doesn't know Svelte 5, they try to import state from runes, for example. And this obviously it's not a thing, it will not work. If they try to import $ state, it will actually error out, so that's fine. But sometimes they try to do stuff like this. And they tried to do, I don't know, Svelte slash, like either for this or Svelte/runes and stuff like that. And initially, you were getting an error in the MCP that told the LLM, please don't do this, just import the runes globally. So we can't technically error on this code at compile time because you might importing state, which is a store, and so we can't really error out. But in the MCP, it's a different world because we know that that code has been written by the LLM. And so in the MCP, we actually throw an error, like we give a suggestion to the LLM that say, hey, if you are importing state because you want to use a rune, don't worry about it. You can just use that globally. And initially, it was like this. So whenever you imported something And so I'm stopping because there is a comment, and I actually fully agree with this comment. That's exactly what I was saying. So the comment was, for the love of God, please don't design the compiler around LLMs. It should be the other way around. And that's exactly what we did. What I'm saying is that in the compiler, we can't really error for this, right? Not because the LLM gets it wrong, because even some people might get it wrong, but we can't error here because you might want to import state. So that's why we can't error. Like, that's something that you might want to do for other reason. And we would never prioritize LLMs over this. But the MCP is a different beast, because inside the MCP, we know that whoever wrote that code is an LLM, and so we can yell at the LLM. And that's why in the LLM, we take more liberty to what we error out on. And so inside the MCP, if you do stuff like this, you will get a suggestion. So like if the LLM writes something like this, the LLM will get a suggestion that says, please don't import state. You are trying to import state, but the reality is that you just need to use state globally. Now, initially it was just like this. So if you imported state from my cool package, this was not error, like it was erroring out initially, right? But then I said, well, maybe you have some state that come from my cool package and it's a store, so we can't really make sure, like we can't really suggest this to the LLM. And so I removed the check and I said, okay, let's do this only if they're trying to import from Svelte or Svelte something, like Svelte rooms, for example. But LLMs are more unhinged than what I anticipated. And so when I was working on a video, I actually saw an LLM do this at Svelte.js / Vite plugin Svelte. And so I said, oh gosh, like, that's just wild. And so I said, okay, let's make it a bit more, like I will broaden the check. And so now basically if it starts with Svelte or at Svelte.js, then it will error out. Because I assume that if an LLM will import state for Svelte, it will do that from either from Svelte itself, from a subpart of Svelte itself, or at least from the official plugins of Svelte. So if you have a package that does Svelte my thing, I don't think LLMs will just assume that to use runes in Svelte, you have to import from a separate package. So I hope, at least. I'm not sure about that, but that was the change that we made. Let's see, we have a new release of Svelte.js open code. For some reason, I don't know why, but the release of the open code 0.1.5 is not anywhere to be seen. There was another change in the open code plugin. Here we are just syncing the skill from svelte.dev. So there is like one of the skills inside the open code plugin, but also like in general, one of the skills is basically derived from the documentation. So if you go to svelte.dev, there is a documentation page on Svelte which is called best practice. So if you want to learn how to write proper Svelte code, you can read best practice here. Now, this is also available as a skill. So what happens is that basically every time someone make a change to this page, the MCP repo gets a notification, and there's some like reworking that we need to do, but then it's available as a skill. So if you want, you can install the Svelte core best practice for your LLM, and this it's actually very effective. So like this is basically a small one page that basically instruct the LLM on what's good Svelte code. And so this was just syncing, so someone fixed something in the main repo and it was synced with the OpenCode plugin. And there's also a small typo in the Svelte file editor agent to use the proper name. And so we released also that. New SV utils. I don't know if I should share these yet. Jean, if you are in the chat, please let me know if I can share this or not. SVCLI, refactor help to give better hints for human and AI. So this was a small refactor that mostly John did. And the reason why we did that is because technically, like, the SVCLI was not non-interactive. It was interactive by default. So if you try to use the SVCLI as a one command, you could do it, but then like it was not easy to figure out what was the default. Like if you had to, like, it will give you a command that you can rerun if you want to redo the same steps, basically. But that was the only way to actually get the parameters out of the SVCLI. And this is basically a small refactor that gives better, like a better help function so that you can actually one line and one shot a Svelte application. Okay, we have a Svelte to TSX, fix use promise response for async kit handler return types. Yeah, okay. And I think that's actually it. There's a new ES wrap. Add TypeScript ESLint types as a dependency, since sometimes are exported. So this is the joy of package management because like if you have a dependency on some types and you are re-exporting that type, then you actually need to have a dependency on it, which is a bit annoying, but it is fine. There is a new question also, which is also interesting, which is, I realized that Vite8 is released using rolldown. Does Svelte already support it? And the answer is yes. You can use Vite8 with Svelte. You do need to use Vite plugin Svelte, the latest version, which has been released, where it is. Yeah, so you need to use the latest version of Vite plugin Svelte that actually requires Vite8, and then you can use Vite8 with rolldown. So I've actually seen people getting a good, performance saving at the build time because of rolldown. So please check out and report any feedback and any issue if you find any. And I think that's it. Okay, I want to show you something. Let's do something else because it's like we have a bit more time. So first thing first, I want to give you this, like if you, I will write the documentation for it. I was waiting for it to be approved, but Svelte is also now a cursor plugin. So if you're using cursor, you can now simply add the Svelte plugin to cursor, to your cursor, and this will give you like the Svelte file editor, sub-agent, two skills, the rules, and the MCP server. So like this is one single package, just like the Cloud MCP, just like the OpenCode MCP, that you can just install and you get everything, and you will likely also get updates. So like if we change some files, you don't have to redo anything. It will just automatically download the new skill or the new file editor. So that's pretty interesting. Another thing that I wanted to show, just to do a small like explainer, is this thing here. So last day I was playing with view transition, which is one of my favorite API ever, because it's very powerful. So, and I did this beauty here. So as you can see, all of this, like I'm using JavaScript to increase the count, but all of this is just built using CSS. In fact, I also built a version that doesn't require JavaScript at all. So this is actually the same version, but it doesn't require JavaScript. So if you see, I have client-side routing false. So there's no interactivity on this page. There's no JavaScript enabled. And I can just click and look at this. Like, this is just working because of View Transition API. And it's so powerful, it's just magic sometimes. It does require some work to be done, but I think it's very cool. And I want to show you how I did this because it could be interesting. So I want to go over the code. Now there are some, to be fair, I'm not a designer, so the nice bits of this demo is actually by Claude. So like the buttons and the nice squares is by Claude. What I did is I styled, like I built the interesting bit and then I asked Claude to style it. But let's see how it goes. So obviously there is a button that use document start view transition here. So with the view transition API, what is happening is that whatever you put inside this callback is inside a view transition. And I will explain a bit how it works, but basically if we go down, like we have an SVG here, and then we have a section, and you see this view transition name here. So the view transition name is something that you need to put as a CSS property on an element. And what this is saying that basically is isolating a piece of UI that will morph when there is a transition. So what happened is basically like the moment I click on this, so let's say that I am here, basically right now there are those three divs, and this div has a view transition name of count 0. This has a transition name of count 1, and this is a transition name of count 2. Now the moment I do this, now this div has a transition name of count 1, this is a transition name of count 2, and this is a transition name of count 3. Now, what does it mean is that when I'm making the change, so in this moment, when I click on the button, what happens is that I am changing within a view transition, and I'm instructing the browser to take a screenshot of every element that has a view transition name on it. So whenever and I can actually show it to you with the very nice animation, playground, because if I pause, so the moment I pause the animations, so this is a tab in your DevTools, when I click on this, you can see that nothing changes, right? And if I inspect the element here, you can see that, so the value, the changes to the elements were already applied. So you can see that like here we have the value of 1 and the view transition name is 1, the value of 2 and the view transition name is 2, the view transition 3 and the view transition name is 3. But then why the UI is not actually changing? The reason why it's not changing is because by the mere fact that I have this view transition name on an element, whenever I make the change, so I clicked on the button, the browser stopped and said, okay, before applying those changes, I will create these view transition elements. So as you can see, this is in the same spot as the 0, and it has a view transition pair and a view transition old of 0. Then there is this view transition 1, which is in the same spot as the 1, and then there is a view transition 2, which is in the same spot as the 2, and a view transition 3, which is also in the same spot as the 3. Now, what happens is that once the browser takes those screenshots, they stay in place, and then an animation start. And so you can see that all these are migrating from one to the other. And I think it's not working now because I pressed something. And so if we repeat the process, it should work better now. So if I do this, I think I need to refresh the page for it to work properly. So let me stop this, I move this. Now you can see that the more I increase, the more the navigation, like the transition happens. And if you take a look, you can basically see how this 0 here, so this view transition 0, which is this one, is basically morphing into the future view transition 0. So since this was here, had a view transition name of 0, and then after the click, this has a view transition name of 0, this element is slowly morphing into this other. And it is like very cool because like it allows you to have this very smooth, basically flip animation that that works with elements of the browser. The important bits, in my opinion, inside this code, like most of this is just pure, let's make it look good. But the important bit is how you actually make this work, which is this part here. So each div, which is this one, has a view transition class of number. And then what I'm saying is that, well, the first child and the last child have a different transform and stuff like that. And then the only thing that I have to do is the moment every div has a view transition class of number, the only thing that I'm saying is that the like where is this is the only child, scale up, scale down. Oh yeah, we don't even need anything more. So like the only reason I'm doing this, I'm styling this view transition. So like you can literally make this work only by, if I remove this code, this still works. It's just a bit uglier because literally the only thing that you have to do is add a view transition name and maybe if you want a view transition class. The moment you add a view transition name, that works. I've added a view transition class because I wanted this thing here. So what I'm saying here is that if the view transition new is an only child, which means that this is going like, it's basically like the view transition new is the only element in the pair, it means that that transition was not present on the page before, and so I scaled it up. And this, I do the same thing with view transition old, only child. And so if the only child, like if view transition old is an only child, it means that for this, like for a certain number, there is only the old version, and in the new version, there's no more that page. So this is basically what happens when you have -1 and you click this, -1 is no more. And so I scale down that thing. And this is basically what allow this effect that -1 is shrinking away. And then I have these keyframes, and that's basically it. And if you want to do this without JavaScript, I think I can. So in JavaScript, what you have to do is that you have to wrap everything that changes something in the DOM inside document.start view transition, but there is even a version of it that's shipped to allow for non-JavaScript interactions, and that's it. So when you are dealing with in a situation where you want to do a view transition without JavaScript, this is literally the only thing that you have to do. So in your global CSS, not even global CSS, sorry. Here you just need to add @viewTransition navigation auto, and this will mean that even when JavaScript is not enabled, when the two pages are literally reloading, when there's no client-side routing, when you switch from one page to the other, every view transition will actually execute, which is super cool because it means that those two can be links now. So like those are not button anymore. I'm just linking to a different page, which has a different count, as you can see up here. And the fact that it has a different count means that when you navigate from one page to the other, since I've added this @view transition here, the navigation will occur and the browser will do all the magic. So yeah, that was just a small thing that I wanted to show you, just like in the name of good old Svelte, this week in Svelte, where we showed you cool stuff. I will prepare some demo for the future because someone was asking a bit of a refresher for how create subscriber works, so I will try to also prepare something for that. All right, guys. Thank you very much for joining. Thank you very much for sticking with me, and I'll see you guys next Friday. Have a nice day. Bye-bye.